In this problem, we're asked to find the acceleration in the x direction and the final speed of a skier who is going down a slope. In this case, the y-axis is perpendicular to the surface of the slope, and the x-axis is parallel to it, so we're using a tilted coordinate system. In order to solve this problem, we'll need to apply Newton's second law, and we'll have to use a kinematic equation. To find the acceleration down the slope, we write Newton's second law in the x direction. This has already been done in problem 1, so the steps are only highlighted here. Essentially, we write the forces in the x direction. Those are the x component of the gravity force and the friction force. We can find the x component of the gravity force by using trigonometry, where this angle between the axis and mg is alpha, where alpha is the incline of the slope. The friction force we can write as the coefficient of kinetic friction times the normal force, where we can then find an expression for the normal force because there's no motion in the y direction, so the y component of the gravity force must equal the y component of the normal force. That means that the normal force is equal to mg times cosine of this angle alpha. Putting all this together, we then have mg sine alpha for the x component of the gravity force minus mu k times mg cosine alpha for the friction force is equal to the mass of the skier times its acceleration in the x direction. Simplifying by canceling the masses and solving for the acceleration, we arrive at this expression here, which after plugging in the numbers given in the problem statement, we find that the x acceleration is 4.13 meters per second squared. To find the skier's final speed at the bottom of the slope, we use a kinematic equation in the x direction involving velocities, acceleration, and a change in distance. In this case, because the skier starts at the top of the hill and goes to the bottom, the change in distance is equal to the length of the slope, which we call d. We can then solve this equation by taking the square root to find that the final speed is equal to the square root of the initial speed squared plus 2 times the x acceleration, which we just found, times the length of the slope. Plugging in the numbers we just found and those given in the problem statement, we find that the speed of the skier at the bottom of the slope is 65 meters per second.